Go.
All right, so we're going to look at section 2.8, which is function operations. So we can add, subtract, multiply, and divide functions. We already talked a little bit about functions in an earlier section, but this section just takes it a little bit deeper. So starting out, this is like number 52 on your study guide. We have two functions, a function f and a function g. And like I said, we can add, subtract, multiply, or divide those functions. If it just says leave an x here, we're going to do it more algebraically and just leave the algebra there. Sometimes there's a number in this parenthesis, and that means fill in that number for the x's and then work it out. But we'll start with this one where we just leave it with the x's. So this means add function f and add function g, add those together. So 5x plus 4 plus 2x minus 7, and then simplify that. You'll have 7x and 4 minus 7, negative 3. So it will be basically y equals that if you want to see it, or f plus g of x equals that, but it just means that's what the function simplifies to. In B part, we're asked to subtract the functions. Function f, the 5x plus 4, minus function g. So I will need to parenthesis that to make sure I distribute my subtract. So 5x plus 4, subtract 2x plus 7, and then combine your like terms. I'll have 5x minus 2x is 3x, and 4 and 7 is 11. So that's the composition of those, just adding or subtracting the functions. C part says to multiply. FG, if there's nothing between it, means multiplication. So that's going to be the FOIL method. Let me scoot this one down a little bit so I have room under it. So F times G would be 5x plus 4 times 2x minus 7, which is FOILing. So I'll first, outer, inner, and last times last, and then combine any like terms. What's 35 minus 8? Let's see.
27.
That is 27. Thank you. Minus 27x minus 28. All right, and that's all you do to it. Since there's not a number here, now in the next example, we may have one that has a number. But if it's just got an x there, we leave it in algebraic terms. That is the answer. D part says to divide. F divided by g of x, leaving it with x. So that means this over this. 5x plus 4 over 2x minus 7, which doesn't actually reduce. That's just the answer. Now, the second part of this question is, now can you tell me the domain and range? I think it asks for both. It just asks for the domain. So when it asks for the domain of each of these, look at it and see if you recognize what type of function it is. On A part, y equals 7x minus 3 was our answer. We know that to be a linear equation. In linear equations, anything goes with the x, so domain is infinity, infinity. Oops. On B part, our answer was 3x plus 11. That's also a linear equation. X to the first, we know that graphs to be a line. The domain of lines is always infinities. You can plug in anything for x. For C part, we multiply our functions and it FOILed out to be a quadratic, x squared. We know that x squared, that anytime you have a quadratic equation, it's some sort of parabola. It might be moved over, shifted, and things, and we'll be talking about that more in the later chapters, but we know it's a parabola, an upright, downright parabola, so it's still a function, and its domain opens left and right. So we're still at infinities. Infinity, infinity. So the domain of a parabola is always open. Now, the last one's going to be our troublemaker. On the last one, you can't just plug in anything for x. I want to erase this so we can focus on it a little bit better. So on the last one, we have a division, 5x plus 4 over 2x minus 7. Y equals, let's say. So anytime you have a fraction function, The problem is you cannot plug something in for x that makes it undefined. So we have to say what would make the denominator equal 0. That's what would make it undefined. It's the only thing we have to worry about in a fraction is set the denominator equal to 0. Solving that, we find that if we plug in x is 7/2, it's going to make it undefined. Anything else is okay. On the fraction ones, you can plug in anything else, and you could test that, analyze it by a t-table, try plugging in other numbers, and working on looking at the graph, and you'll find everything else is okay. So this is the thing it cannot equal. So when we write the domain, we write it in the affirmative. What can it equal? The domain can be anything up to 7/2, but not including 7/2, and then union 7/2 to infinity. This is our way of writing everything except what makes it undefined. That would be, because you know brackets mean you include it. So a parenthesis means we don't actually include the 7/2, but just everything really close to it. All right, so that's how we handle number 52. Let me find another one to tag on with that. Okay, let's say number 49. Let's go to 49. Here's a sample of number 49, and we're doing f minus g at -4. So this one gives us a number to plug in for x. Unlike the last example, f minus g, you subtract these, but then you also plug in -4 for the x values. So you can plug in -4 for the x values and make those numbers first, or you can plug it in after you do the algebra. It's kind of up to you. I'm going to go ahead and subtract the functions first like we did previously. So f minus g would be function f, subtract function g, which I do need a parenthesis when I subtract to remember that I have to distribute the subtraction. So function f minus function g, combine your like terms, distribute, and simplify that. All right, so that combines down to a nice quadratic equation. And that would be the answer if this were just an x, right? Like on the last thing we did. But where it has a number there, this parenthesis always means plug that in for the x value. So x is -4. So then we do another step where we put -4 in for the x's, and we work this one all the way out. So you can type it on your calculator, but that would be 16 times 5 is 80. That's -16 plus 1. Y'all want to help me out? Is that 65, I think? So we get an ultimately like a real-time just number answer to that one. All right, so again, subtraction, we can add, subtract, whatever it says to do here, you take your functions, do that work, add, subtract, multiply, divide. And then if there be a number there, we plug that in for the x and work it out. Okay. One more type of operation we do on functions that's on your study guide, and this would be the new thing, I think, the more add-in thing that they put in 2.8. And that's what if there's this little open circle. So we want to look at the last problem, I think it is on your study guide. It's called a composition function on 55. This is called composition of functions. And it's when you plug a function into a function. Plugging a function into another function. And it looks like this little open circle, like that. So on number 55, we see fog f of g is how we read that, f of g of x. And again, there can be an x or a number, just like the other stuff I said. We'll start with just having an x there. So it says do f of g of x, and then we're going to do it the other way, g of f of x. Again, this is called a composition of a function when you plug a function into another function. The little open circle means that. You always plug the second function into the first function. Sort of like order of operation, you do the innermost part first. So we've plugged function G into function F. I forgot to write the functions, didn't I? So we have a function F and G defined. In my sample one here, I'll write these problems down we can use. So we've got function F defined, function G defined. To do F of G, we take all of function G and plug it into function F. Now, if there be more than one x, you plug it into any and all of the x's. We just have the one little x there. So it's going to be -6. Instead of x, we plug this function into it, plus 9. So that's what fog looks like. Function G plugged into function F. And then we simplify it. So that's -18x minus 54 plus 9. And that is 45. And then that's it. That is the answer. If there be a number there, you have to follow up and plug in your number and work it out. I'm going to go the other way now, so that's fog. Let's do it again as golf, G of F of x. So we're going to plug function F into function G. We're going to do it the other direction. So back up here to where my directions were, I've got the two F and G functions. So we take function F, plug it into function G this time. So go the other way. So it's always the second one into the first one. So function G, 3x plus 9, we change our x into this stuff. And everything else stays the same. The 3 is still there, the 9 is still there, but where there was an x, we plug in function F. Then we distribute, and we simplify. And that is the answer. We just plug it in with the algebra there.